Okay, we have just a few minutes to start, which is totally fine. We're going to take a look in this section at a preview of calculus. So to start with, calculus. What is calculus? Calculus is actually the mathematics of change. And that's all you really need to write in that blank there is the mathematics of change. And there's a couple more things that you might want to write as we're taking a look at these different slides. All of these slides are in your textbook on pages 47, 48, but putting them in the slideshow and in your notes would have been like bulky, and so I left them out. But the basic idea of all of them is that there's a difference between the way that we think in pre-calculus and the way that we think in calculus. And these are a series of examples of the differences. That's what it really is. And as we're taking a look and going through these, some of them, they will happen this semester. Some of them don't happen this semester, so we're going to kind of move through them quickly on those ones. Like, yeah, it's going to happen in Calc 3. Some of you may never get there. That's fine. But there's a lot of differences between what we do in those two kinds of courses. So the first one, without calculus or with pre-calculus, we are able to find the value of a function. You can kind of see there's a pointed arrow there. We can find that y value. If we've given the x value, we can find the y value if we know the function itself, right? Either the graph for it maybe or the equation for it. We can find the value. But if we're looking at calculus, we can actually find the limit or the value that we're approaching if the point we're missing, like it's an open circle. So limit, we'll talk more about those later. That's the whole first chapter we're going to look at. Limits are values we get close to, and we may or may not ever get there. We can do that with differential calculus. Without calculus, we can find the slope of a line. In fact, you all know how to do it. You've been doing it since pre-calc, right? It's been a long time since you've started the idea of finding slope. But you only found slope for lines. But with calculus, we can actually find the slope of a curve. Right? How much is the curve sloped at that point in time? Which is a bit more practical when you're thinking about like roads. Roads aren't lines, right? They're usually on some kind of a hill when people are talking about how steep a slope is. It's not usually a line. With pre-calculus or without calculus, we can find a secant line to a curve. So a secant line is a line that connects, remember this probably from like a geometry class. If you take 2 points on the curve, you can draw a line through it, you can find its slope. That's a secant line, okay? So you can find a line between any 2 points. It's almost hard to see on this screen. This is the line they're drawing there. With calculus, you can actually find a tangent line. So tangent lines, again, if you'll remember from geometry, are lines that just sort of barely touch something and they bounce off, right? I've had students describe them before as that it kisses the line, right? It just this barely touching kind of thing. And so you're able to find this line here. You can't do that with pre-calculus, but you can do it with calculus. With pre-calculus, you can find the average rate of change between 2 points. Okay, you can find averages with pre-calculus. But with calculus, you can find the instantaneous rate of change at a particular point. So what is that? Well, that's the difference between saying how fast I'm going right now in my car, right, looking at the speedometer, and how fast on average I would go over, my trip from my home to Shawnee. I live about 20 minutes away. How long does it take on average? What is my average speed? Right, this is the difference. So far, all of those things that we've done are things that we're actually going to do in Calc 1. The next one is not Calc 1. It's Calc 2, curvature of a curve. So in pre-calc, you can find the curvature of a circle. So you can find how curved the circle is. But when you're using calculus, you can actually do that for any curve. It doesn't have to be a circle. And that's a Calc 2 concept, and also in Calc 3. The next one's a Calc 1 again concept as well. You can find the height of the curve. You can just find, this is almost the same as the very first piece that I showed you. You can find that point, the y value, right? But with calculus, you can actually find the maximum point of a curve. Now, you can do that with some things in pre-calc, like you could find, the vertex of a parabola as a maximum. But once it turned to a cubic function, you were doing things with graphing calculators and tracing if you were looking for that. You weren't able to find it with algebra, right? Like that's not possible. It takes calculus to do it. The next one, tangent plane to a sphere and tangent plane to a surface. This is Calc 3. So a tangent plane to a sphere, you can do that with pre-calculus. But it takes calculus, specifically at our university, Calc 3, before you can do that to any surface, finding a tangent plane to a surface. You can find the direction of motion along a line with pre-calculus. But if you want it to be a general curve, it takes calculus. So the feeling you should be getting as we're working is that pre-calculus is like, I can do these things in very specific situations, right? But with calculus, you can do it for these broad categories of things that are just like for anything. I can do it for anything if I have calculus. I think this is the last slide. Nope, there's 2 more. Okay, we'll do 1 more of these and we'll stop. Area of rectangles. Y'all know how to do that, right? That's one thing my 3rd grader's working on right now. Area of a rectangle. You can do that with pre-calculus or 3rd grade math. And in order to do it as a general statement under a general curve, right, that area, you need calculus. We will do that this semester. Work done by a constant force. That's pre-calculus. Work done by a variable force. That's Calc 2. Finding the center of a rectangle. You can do that with pre-calculus. Right? Usually in a geometry course you do that in high school. Finding it for a central area of any general region. Again, that arbitrary shape. That's calculus, and we do that in Calc 2 as well. The length of a line segment, you can do that with pre-calc. Like that's where you just find length, right? Distance formula kind of stuff. But if you want the length of a curve, that's Calc 2. Okay? Let me just run through these real quick. It'll take me 1 minute. Surface of a cylinder, that's geometry. Surface of a solid of revolution, Calc 2. These funny shapes, right? The mass with a constant density, you can do that with pre-calc. Mass with a variable density, Calc 2 and Calc 3. Volume of a rectangular solid, that's geometry, right? Pre-calc. Volume under a region, that's Calc 2. Sum of a finite number of terms, right? If you add the numbers from 1 to 100, you can do that with pre-calc. We do it in my elementary math classes, in fact. Not a problem. They don't like it, but it's not a problem. In order to do it for an infinite number of terms, that's Calc 3. So what we're going to start with next time is taking a look at 2 very specific examples and how we can use pre-calculus to estimate things that calculus can find for us exactly. And we'll stop there for today.